course. So before we begin, let's have a quick look at the agenda of this session. So first of all, I'll be starting off by explaining you guys about the evolution of data, how it led to the growth of data science, machine learning, AI, and all the different aspects of data. Then we'll have a quick introduction to data science, understand what exactly it is. Then we'll move forward to the data science careers and the salary and understand what are the different job profiles in the data science career path, how to become a data scientist, a data analyst, or a machine learning engineer. Then we'll move on to the first and the foremost part of data science, which is statistics. And after completing statistics, we'll move on to machine learning, where we'll understand what exactly is machine learning, what are the different types of machine learning, and how are they used, and where are they used, the different algorithms. And next, we'll understand what is deep learning and how deep learning is different from machine learning. What is the relationship between AI, machine learning, and deep learning in terms of data science? Exactly neural network works, how to create a neural network, and much more. So let's begin our session. Now, data is increasingly shaping the systems that we interact with every day. Whether you are searching something on Google, using Siri, or browsing your Facebook feed, you are consuming the result of data analysis. It is increasing at a very alarming rate, where we are generating 2.5 quintillion bytes of it every day. Now, that's a lot of data. And considering there are more than 3 billion internet users in the world, a quantity that has tripled in the last 12 years, and 4.3 billion cell phone users. That's a heck lot of data. And this rapid growth has generated opportunity for new professionals who can make sense out of this data. Now, given its transformational ability, it's no wonder that so many data-related jobs have been created in the past few years, like data analysts, data scientists, machine learning engineers, artificial intelligence engineers, and much more. Now, before we delve into the details of all of these different professionals, let's understand exactly what data science is. So, data science, also known as data driven science, is an interdisciplinary field about scientific methods, processes, and systems to extract knowledge or insights from data in various forms, either structured or unstructured. It is the study of where information comes from, what it represents, and how it can be turned into a valuable resource in the creation of business and IT strategies. So, data science employs many techniques and theories from fields like mathematics, statistics, information science, as well as computer science, and can be applied to small data sets also. Yet, most people think data science is when you are dealing with big data or large amounts of data. So, this brings the question, which job profile is suitable for you? Is it the data analyst, the data scientist, or the machine learning engineer? Now, data scientist has been called the sexiest job of 21st century. Nonetheless, data science is a hot and growing field. So before we drill into data science, let's discuss all of these profiles one by one and see what these roles are and how they work in the industries. So data science career usually starts with mathematics and stats as the base, which brings up the first profile in our data science career path, which is a data analyst. So a data analyst delivers value to their companies by taking information about specific topics and then interpreting, analyzing, and presenting the finding in comprehensive reports. Now, many different types of businesses use data analysts to help. As experts, data analysts are often called on to use their skills and tools to provide competitive analysis and identify trends within the industries. Most entry-level professionals interested in going into data-related jobs start off as data analysts. Qualifying for this role is as simple as it gets. All you need is a bachelor's degree in computer science, mathematics, and a good statistical knowledge. Strong technical skills would be a plus and can give you an edge over most other applicants. So next we have data scientist.
51 रुपए में 12वीं की कोचिंग, इसमें बोर्ड एग्जाम में कुछ मदद भी.
But in simple words, a data scientist is the one who practices the art of data science. The highly popular term data scientist was coined by DJ Patil and Jeff Hammerbacher. Data scientists are those who crack complex data problems with a strong expertise in certain scientific disciplines. They work with several elements related to mathematics, statistics, computer science, and much more. Now, data scientists are usually business analysts or data analysts with a difference. It is a position for specialists, and you can specialize in different types of skills like speech analytics, text analytics, which is the natural language processing, image processing, video processing, medicine, simulation, material simulation. Now, each of these specialist roles are very limited in number and hence the value of such a specialist is immense. Now, if we talk about AI or machine learning engineers, so machine learning engineers are sophisticated programmers who develop machines and systems that can learn and apply knowledge without specific direction. Artificial intelligence is the goal of a machine learning engineer. They are computer programmers, but their focus goes beyond specifically programming machines to perform specific tasks. Now, they create programs that will enable machines to take actions without being specifically directed to perform those tasks. So now if we have a look at the salary trends of all of these professionals, so starting with a data analyst, the average salary in the US is around $83,000, or it's almost close to $84,000, whereas in India it's around 4 lakh and 4,000 rupees per annum. Now coming to data scientists, the average salary is $91,000, $91,500, and in India it is almost 7 lakh rupees. And finally, for ML engineers, the average salary in the US is around $111,000, whereas in India is around 7 lakh and $20,000. So as you can see, the data scientist and ML engineers position are a certain higher position which requires certain degree of expertise in that field. So that's the reason why there's a difference in the salary of all the three professionals. So if we have a look at the roadmap of becoming any one of these professionals, so what first one needs to do is earn a bachelor's degree. Now this bachelor's degree can be in either computer science, mathematics, information technology, statistics, finance, or even economics. Now after completing a bachelor's degree, the next comes is fine-tuning the technical skills. Tuning the technical skills is one of the most important parts in the roadmap, where you learn all the statistical methods and packages. You either learn R, Python, or SAS languages, which are very important. You learn about data warehousing, business intelligence, data cleaning, visualization, reporting techniques. Working knowledge of Hadoop and MapReduce is very, very important. And if we talk about machine learning techniques, it is one of the most important parts of the data science career. Now, apart from these technical skills, there are also some business skills which are very much required. So this involves analytical problem solving, effective communication, creative thinking, as well as industry knowledge. Now, after fine-tuning your technical skills and developing all the business skills, you have the options of either going for a job or either going for a master's degree or certification programs. Now, I might suggest is you go for a master's degree, as just coming out of the BTech world and having the technical skills is not enough. So you need to have a certain level of expertise in the field. So it's better to go for any master's or PhD programs which are in computer science, statistics, or machine learning. You can also go for big data certifications, and you can also go for industry certifications regarding the data analysis, machine learning, or the data science. It so happens that Edureka also provides a machine learning, data analysis, as well as a data science certification training. They have master's programs which are equivalent to the master's degree which you get from a certain university. So do check it out, guys. I'll leave the link to all of these in the description box below. And after you have completed the master's degree, what comes is working on the projects which are related to this field. So it's better if you work on machine learning, deep learning, or data analytics projects. That will give you an edge over other competitors while applying for a job scenario. So a certain level of expertise in the field is also required. And this is how you will succeed in the data science career path. There are certain skills which are required, which I was talking about earlier, the technical skills and the non-technical skills. Now, if we talk about the skills which are required to become all of these professionals, so they are mostly the same. So for any data analyst, first of all, you need to have analytical skills, which involves maths, having good knowledge of matrix multiplications, the Fourier transformations and all. Next, we have communication skills. So company looking for a data analyst requires someone who has the good communication skills, who can explain all of the technical terms to non-technical teams, such as marketing or the sales team.
मेरे मैनेजर को पता नहीं है कि मैं पिछले 2 महीनों से इंग्लिश प्रैक्टिस कर रही हूँ और उसे लगता है कि मेरी इंग्लिश काफ़ी अच्छी नहीं है। आज मैं उसे सरप्राइज देने वाली हूँ।
Sales team. Another important skill required is critical thinking. You need to think in certain directions and gain insights from the data. So that's one of the most important part of a data analyst's job. Obviously, you need to pay attention on the details, so as a minor shift or the deviation in the result or in the calculation, what you say, the analysis, might result in some sort of loss of your company. It's not necessarily to create a loss, but it's better to avoid any kind of deviation from the results. So paying attention to the detail is very, very important. And then again, we talk about the mathematical skills. Knowing about all the types of differentiations and integrations is going to help a lot, because a lot of machine learning algorithms, as I would say, are mostly mathematical terms or mathematical functions. So having good knowledge of mathematics is also required. Apart from this, the usage of technical tools such as Python, R, we have SAS. You need to know about the big data ecosystem, how Hadoop works, the HDFS, how to extract data, create a pipeline. You need to know about JavaScript a little. And if you talk about the skills of data scientists, it's almost the same, having analytical and statistics knowledge. Now, another important part here is to know the machine learning algorithms, as it plays an important role in the data science career. Problem solving skills, obviously. Now, another important aspect, if we talk about the skill which differs from that of a data analyst, is importantly deep learning. So deep learning, I'll talk about deep learning later in the second half or the later part of this video. So having a good knowledge of deep learning and the various frameworks such as TensorFlow, PyTorch, you have Theano, all of this is very required for data scientists. And again, business communication, as I mentioned earlier, is very much required, because as you know, these are one of the technical roles, most technical roles in the industries. And the output of these roles, or what I would say, the output of what these professions do, is not that much technical. It's more business oriented. So they have to explain all of these findings to either the non-technical teams, the sales, the marketing, and again, you need the technical tools and the skills. Now, for machine learning engineer, obviously programming languages, having good knowledge of R, Python, C++, or Java is very much required. You need to know about calculus and statistics, as I mentioned earlier, learning about matrices, integration. Now, another important skill here is signal processing. So a lot of times machine learning engineers have to work on robots and signal processing. They work on human-like robots. They work on robotics which mimic human behavior. So a lot of signal processing techniques are also required in this field. Applied mathematics, as I mentioned earlier. And again, neural networks. It is one of the base of artificial intelligence which is being used. And again, we have natural language processing. So as you know, we have personal assistants like Siri and Cortana, and they work on language processing. And not just language processing, you have audio processing as well as video processing, so that they can interact with the real environment and provide a certain answer to a particular question. So these were the skills, I would say, for all of these three roles. Next, if we have a look at the peripherals of data science, so first of all, we have statistics. Needless to say, there are programming languages, we have software integrations, then we have machine learning, which is a big part of data science, and then again, we have big data. So let's start with statistics, which is the first area of data science, or I should say the first milestone which we should cover. So for statistics, let's understand first what exactly is data. So data in general terms refers to facts and statistics collected together for reference or analysis. When working with statistics, it's important to recognize the different types of data. So data can be broadly classified into numerical, categorical, and ordinal. Now, data with no inherent order or ranking, such as a gender or race, is called nominal data. So as you can see in the type 1, we have male, female. That is nominal data. Now, data with an ordered series is called ordinal data. So as you can see here, we have an ordered series where we have the customer IDs and the rating scale. Now, data with only two option series is called binary data. Now, in this type of data, there are only two options, like either yes or no, or true or false, or 1 or 0. So as you can see here, we have customer ID, and in the owner or car column, we have either yes or no. Now, the types of data we just discussed until now describe the quality of something in size, appearance, value, or something. Such kind of data is broadly classified into qualitative data. Now, data which can be categorized into a classification, data which is based upon counts, there is only a finite number of values possible, and the values cannot be subdivided meaningfully, is called discrete data. So as you can see here in our example, we have organization and the number of products. So this cannot be subdivided into number of sub-products, right?
पूजा तुम्हारी इंग्लिश न बोल पाने की वजह से the foreign client has cancelled the deal.
I try, sir, but client
Sub-products, right? And if we talk about data which can be measured on a continuum or a scale, Now, data which can have almost any numeric value and can be subdivided into finer and finer increments is called continuous data. So as you can see here in patient ID, we have weight of the patient. It's 86.5 kgs. Now kgs can be subdivided into grams and milligrams, and finer refinement is also possible. Now this type of data that can be measured by the quantity of something rather than its quality is called quantitative data. Now that we have understood the different types of data, qualitative and quantitative, it's time to understand the types of variables we have. Now there are majorly two types of variables, dependent and independent variables. So if you want to know whether caffeine affects your appetite, the presence or the absence of the amount of caffeine would be the independent variable, and how hungry you are would be the dependent variables. So in statistics, dependent variable is the outcome of an experiment. As you change the independent variable, you watch what happens to the dependent variable. Whereas if you talk about independent variable, a variable that is not affected by anything that you or the researcher does, usually plotted on the x-axis. Now the next step after knowing about the data types and the variables is to know about population and sampling, and that comes into experimental research. Now in experimental research, the aim is to manipulate an independent variable and then examine the effect that this change has on a dependent variable. Now, since it is possible to manipulate the independent variable, experimental research has the advantage of enabling a researcher to identify a cause and effect between the variables. Now, suppose there are 100 volunteers at the hospital, and the doctor needs to check the working of a particular medicine which has been cleared by the government. So the doctor divides those 100 patients into two groups of 50 and then asks one group to take one type of medicine and the other group to not take any medicine at all. And then after a week, then compare the results. And in non-experimental research, the researcher does not manipulate the independent variable. This is not to say that it is impossible to do so, but it will either be impractical or it will be unethical to do so. So for example, a researcher may be interested in the effect of illegal recreational drug use, which is the independent variable, on certain types of behavior, which is the dependent variable. However, whilst possible, it would be unethical to ask any individual to take illegal drugs in order to study what effects this had on certain behaviors. It is always good to go for experimental research rather than non-experimental research. So next in our session, we have population and sampling. Those are two of the most important terms in statistics, so let's understand these terms. So in statistics, the term population is the entire pool from which a sample is drawn. Statisticians also speak of a population of objects or events or procedures or observations, including such things as the quantity of the number of vehicles owned by any person. Now, population is thus an aggregate of creatures, things, cases, and so on. And a population commonly contains too many individuals to study conveniently. An investigation is often restricted to one or more samples drawn from it. Now, a well-chosen sample will contain most of the information about a particular population parameter, but the relationship between the sample and the population must be such as to allow true inferences to be made about a population from that sample. For that, we have different types of sampling techniques. So in probabilities, there are sampling methods which are classified either as probability or non-probability. So in probability sampling, each member of the population has a known non-zero probability of being selected. Probability methods include random sampling, systematic sampling, and stratified sampling. Whereas in non-probability sampling, members are selected from a population in some non-random manner. Now these include convenience sampling, judgment sampling, quota sampling, and snowball sampling. While sampling is important, there is another term which is known as sampling error. So sampling error is the degree to which a sample might differ from the population. When inferring to a population, results are reported plus or minus the sampling error. Now in probability sampling, there are three terms which are random sampling, systematic sampling, and stratified sampling. So talking about random sampling, probability of each member of the population to be chosen has equal chance of being selected. Such type of sampling is random sampling. Now if you talk about systematic sampling, it is often used instead of random sampling, and it is also called the nth name selection technique. Now pay attention to the name called nth name. So after the required sample size has been calculated, every nth record is selected from the list of the population member. Now its only advantage over random sampling technique is its simplicity.